So good morning everyone. So the first unit we studied already. It introduces what are the different logic families available and how to construct various logic gates under different logic families. How to interface one logic family with the another logic family. So without affecting the end result. Now coming to second unit onwards, the second unit introduces one of the HDL, that is hardware description language. The rest of the units you know already. You are going to develop some HDL programs for combinational circuits, sequential circuits, etc. Coming to second unit, it introduces the language VHDL. What is the purpose of HDL means? It helps to develop a software program for our digital circuits. Why you need to develop software programs to our digital network means, nowadays you know each and every domain uses software tools. Already you did one laboratory like ECA, electronic circuit analysis. Here you did the experiments in both hardware laboratory and also software laboratory. So I think already you identified the difference between software laboratory and hardware laboratory. So by using software laboratory or software tool, the advantages like the designing process is very easy, it takes very less time, and you can easily change the modifications in the design process in order to satisfy user requirements. And cost also very less, because here there is no physical components, everything is virtual, so that's why the cost is very less. So that is the reason why nowadays almost all domains uses the software tools. So coming to our syllabus, so here we can learn one of the HDL language, that is VHDL. The purpose of this language is, using this language you can develop software program for various digital systems or digital circuits, so that you can enter our digital designs into the software environment easily. So that is the purpose of the HDL. Then coming to that is, suppose if the any design process based on the HDL, it has several steps. All those steps categorized as two groups. One is called front end design group, front end design, and another one is back end design. So the front end design includes steps like block diagram, hierarchical block diagram, coding, the process of compilation, and simulation or verification. These are the different steps you can observe, or all these steps are grouped as front end. Coming to one by one, first of all, developing the block diagram or logic diagram. So as per the user requirements, you need to develop a logic or block diagram first of all. Already you studied in STLD subject how to develop or how to realize a digital circuit as per the user requirement. Then writing a VHDL program or a HDL program using any HDL language, that is done in the process coding. After coding, you need to compile it. Compilation is for checking the syntax errors, and also it checks is there compatibility between one module to the another module. Suppose if the syntax errors present or compatibility is not good in between the modules, you need to change the code. After compilation process is okay, then you need to simulate it. or verification. Simulation means verification it is. So if the verification done by using a software tool, then it is called simulation. Okay, here the type of verification is functional verification. The type of verification is functional verification. That means our developed code, HDL code, satisfying the truth table of digital system or not. That we are going to check in the simulation process. These are the different steps in the front end. Then coming to back-end design, it includes different steps like synthesis, placement and route, timing verification. Usually all these steps based on the target device. Usually the target devices are CPLDs or FPGAs. In those devices, we are dumping our entire code and verifying the functionalities. Then coming to synthesis process. In the synthesis process, what happens means it converts our HDL program into a list of gates. Suppose if you take a HDL program for an half adder, the synthesis process represents, or the output of the synthesis process is a list of two gates. One is XOR gate and another one is AND gate. Why? Because in half adder we have two gates. In the logic diagram of half adder we are using one XOR gate and one AND gate. So that is the process of synthesis. It converts HDL program into gate level netlist. After that, the process is called placement and route. In placement and route, what happens is whatever the list generated by the process of synthesis, those gates or blocks properly placed in the given area and also routed properly to avoid delays, etc. Then coming to timing verification, here we are checking is it satisfying user timing requirement or not, and also it checks different delays like different times, maybe different times like hold time, setup time, etc. By observing all those delays and timings, so is it satisfying user time or not, that thing you can do in the verification process. So these are the various steps you can observe in the design process if it is based on HDL, called design flow, also called here the type of language is VHDL, so that's why it is also called VHDL design flow diagram. Okay, and coming to our language, okay, our language is of course VHDL. There are two types of very popular HDL languages are two types. One is VHDL and another one is Verilog HDL. In our syllabus we have the language VHDL. It means VHSIC HDL. VHDL stands for VHSIC. V represents VHSIC HDL. HDL means hardware description language. Then coming to VHSIC, it means very high speed integrated circuit. Very high speed integrated circuit hardware description language. This is the total expansion for VHDL. It was developed by US Department of Defense. Okay. Then coming to the programming structure or design units of this language. This VHDL language having 5 design units named as entity declaration, architecture body, configuration declaration, package body and package declaration. Okay, so like that we have 5 design units. Out of 5 design units, in order to develop a program in the VHDL, only the first 2 are enough. write the program, the first two design units are enough. So that is, you can see the programming structure is appeared like this. So minimum 2 design units you have to use. Those are entity declaration and architecture definition, or architecture body also you can call. Entity declaration means it declares all the inputs and outputs of a digital system. In that entity declaration, what happens means, here you can define all the inputs and outputs of a digital system. Whereas in the architecture body, the internal operation of the digital system represented through architecture body. So these two are must in any VHDL program. Okay. So let us see the syntax of, first of all, for entity declaration. The syntax of entity declaration starts with the word entity. Okay, the syntax of entity declaration start with the word entity followed by name of the entity. Name of the entity is, here this is the first line in the syntax of entity. Here I represented name of the entity in the capital letters. Why? Because the name is user defined name. The name is user defined name, whereas some words like entity is are written in small letters. Why? Because these are keywords or reserved words already used in the language. So this is the first line in the syntax of the entity. Then coming to second line, start with the port of signal names colon mode type semicolon. Okay. So in the port you can define different signals, different signal names. You can place different signal names, that is input signals and output signals. So whatever the signal, it is represented in the signal name followed by colon. After that, mode represents the direction of that particular signal. That means, is it input signal or output signal, or it may act as input and output. That is represented through the mode. Okay. And then type means what type of data the signal has to be accept. The type represents, there are many predefined data types in the language. Those types you need to represent here. Their purpose is what type of data the signals may accept. Okay, so like that, any signals you can declare in the port, and the port is ended by a closing bracket and semicolon, and finally end with entity name or not. So end is must, the word end is must, but entity name is a optional one, so ended with the semicolon. So this is the syntax for entity declaration. Okay, it start with the word entity, then entity name, it is a user defined name is. The next line, port of user defined signal names colon modes. Mode represents the direction with the different words. You can see what type of modes are available like that, and types. Type represents the what type of data the signals can accept. There are many predefined data types. That predefined data types what available in the language, that also you can see in the further classes. So like that, many signals you can define. Finally end with the entity name, but entity name is the optional, so close it with the semicolon. Okay, suppose if you take an half adder an example, let us write the entity declaration for it. Suppose if you take an half adder, it has two inputs named, one input is A and another input is B, and it has two outputs. The name of two outputs are sum and carry. Okay, so this is the simple half adder with two inputs and two outputs, and also here the two inputs are A and B, two outputs are sum and carry. So let us see the entity declaration for this half adder. Already you know the syntax of entity is entity. It start with the word entity. Start with the word entity. Then as per syntax, name of the entity, which I said already, this is user defined name. Here I named it as half underscore adder, followed by it is. This is the first line. Okay, so to give the name, to write the name, you need to follow certain rules. Usually the name is referred as identifier in the language. What are the rules you need to follow for the identifiers, that you can see in the further classes. Okay, so next, coming to as per syntax, here port of a comma b colon, here mode is in, then type is standard logic. So here what is A and what is B? A and B are the input signals. As per the half adder circuit, A and B are the names of input signals. So signal names here A comma B. You can write separately or you can write in the same line like this. Colon followed by mode. Here mode type is in, because A, B both the signals are input to the half adder. That's why it is the mode word is in. Then type means data type. I said already what type of data this A input and B input can accept. So the predefined data type is standard logic. Actually it is a 9-value logic. So usually in the digital circuits, the type of data is binary data, that is zeros and ones. So in for that, the standard logic is the data type we are using. So then in the second line, I represented output signals. As per the given example, the output signals named as sum and carry. So sum, carry. So both these signals mode is out. Then followed by data type is standard logic. Okay. So now all input signals and output signals we represented. So therefore close the port with the closing bracket, then semicolon. After that, end with entity name. Okay, so whatever the entity name you represented in the line entity, the same name you have to use here, and entity name, semicolon. Okay, so like that, this is the syntax of the half adder. Okay.